Good morning, guys. Welcome to my channel. So, the today's lecture is about complexity of the approaches and performance of the approaches. So, if I finish these two topics, your natural language process unit 1 will be completed, right? Then we'll go to the topics. Yeah. So, here complexity of the approaches. So, first of all, we need to know about why. First of all, see, remember very clearly. First of all, we need to know why it is required. So, that means why need to calculate the complexity of your method or model. Why it is required? Because need to check the model accuracy, how it is working, and which method or which approach is better than other one, and which method is accurately predicting the results, and which method is suitable for our required inputs. So to know about all these things, we need to check the complexity of our methods. So for checking the complexity of the approaches, what we need to do here, we need to measure the complexity by using the training of the approach, training of the model, or performance of the model. Okay, so here we need to measure the complexity, right? So this if you know the complexity of an approach, easily we can tell that which approach is better giving results, better predicting the result, and better working, like that. So here, see, for example, here we are having a training of discriminative approach is more complex than training of generative approach. So here we are comparing the two methods, right? So discriminative approach and generative approach. So training of this method is more complex than training of this generative method, because they require a multiple passes over the training, because this discriminative method need multiple tasks to train that model, multiple passes over the training data to adjust the features of your data. So that's why, see, after calculating the complexity of this method and discriminative method and generative method, we given that discriminative method is more complex than generative method. Okay, so same like that, one more example here I given the, see here, discriminative classification allows a wider variety of the features. So because we are having a discriminative sequence and discriminative local classification, the two versions we are having in the discriminative approach. So if you consider the two versions, it will allows a variety of features and performs better smaller training sets, smaller training sets. So that means we need to combine all these smaller training set. It will make more complex. Then predicting with a discriminative complex, see here, predicting with the discriminative classifications is lower because it is dominated by the cost of extracting the more features. Due to the multiple local information, due to this local information, we need to extract the local features of each and every information, right? So due to this thing, it will give the lower results, and also it will cost of extracting more features. So cost also very more, and it will give the lower results, and also to build this model and to train this model, it is very complex, right? So here we measure the complexity by rating the training and prediction of the methods. So by training the method and by predicting the result of the method, we will say that which method is giving a better results, which method is predicting the good accurate results, and which method is giving better performance. Okay, so these are all the simple examples of the what is this complexity of the approaches. Okay, this one. Then we will go for performance approaches. So performance of the approaches. So here performance of the approaches, by calculating the performance of a particular approach, we can say that how that method will be working, right? So here this performance can be measured with some performances metrics. So what are the performances metrics we are having? So normally this performance metrics, while training the machine learning model and deep learning model, we can calculate all these performances metrics. So same methods and same metrics here also we will use, but these performances metrics can be used for sentence segmentation of the speech or text. Sentence segmentation of the speech or text. So after segmenting the sentences and text, what is the sentence boundary and topic boundary, then we can calculate that error percentage rate of your model and precision of your model and recall of your model and F1 score of your model. Okay, so here first thing, error percentage rate. So how to calculate a error percentage rate of a particular method or model is, see here, number of errors. So this number of errors while training the model or while validating the model or while testing the model, how many number of errors you will occur, you will get that all number of errors count divided by total number of examples. So that means the total number of examples means in your data set how many examples you considered to check the performance of a particular method. Okay, so then coming to that precision. So how to calculate the precision? So see here, total number of correct positive predictions. So total number of correct positive predictions divided by total number of positive predictions. So we will get so many positive predictions, right? So maybe or may not be it will work, but from that total number of positive predictions you can choose a correct positive predictions. That means based on the past results, the nearby results you have to choose. So that is total number of correct positive predictions divided by total number of positive predictions. We will get the precision of a particular method. Then coming to, we need to calculate one more performance metrics, that is recall. So recall is total number of correct positive predictions. So same here, the above in the precision what we are considering in the nominator, that you have to enter here the positive predictions divided by total number of positive instances. So positive instances means, so remember here, positive instances means the total number of positive predictions and also false positive predictions together. So false positive predictions plus positive predictions, that total you can put in the denominator. So you will get the recall result of a performance metric of a particular method. Then finally F1 score. So after calculating the precision, recall, then you can calculate the F1 score along with these two metrics, that is 2 multiplied by precision multiplied by recall divided by precision plus recall. So you will get the F1 score. So based on all these performance metrics values, we can analyze and we can judge that our model, our particular method is how accurately giving the results and how accurately predicting the results and better results. So based on that results, we can say that the model how complex it is, for building the model or for analyzing the model, how complex it is. Hope everyone will understand these topics. Thank you very much, guys. Please support my channel. Thank you so much. Bye everyone.